So today we will discuss data warehouse bus structure matrix. It is built upon the concept of confirmed dimension that are interlinked by facts. The data warehouse is a major component of the solution required to transform data into actionable knowledge. The schema-on-write methodology supports business intelligence against the actionable knowledge. So if we already know and there is a fixed structure, then we can go for data warehouse bus matrix. Now, there are various data science processing tools. So we will see the data science processing tools one by one. First, let's see the Apache Spark. It's an open source cluster computing framework. Then we have the Spark code. It is the foundation of the overall development. It provides distributed task dispatching, scheduling, and basic I/O functionalities. Spark SQL is a component on the top of Spark code that presents data abstractions called data frames. Spark Stream leverages Spark core fast scheduling capability to perform streaming analytics. Then we have Spark MLib is a distributed machine learning framework used on the top of the Spark core by means of the distributed memory-based Spark architecture. Then GraphX. It's a powerful graph processing application programming interface for Apache Spark analytic engine that can draw insights from large data sets, and it can present it graphically to the users who perform the query. Then Apache Mesos is an open source cluster manager. It delivers efficient source isolation and sharing across distributed applications. The software enables resource sharing in fine-grained manner, improving cluster utilization. Kafka is an actor-based message-driven runtime for running concurrency, elasticity, and resilience processes. Then we have Apache Cassandra. It's a large-scale distributed database supporting multi-data center replication for availability, durability, and performance. Kafka is a high-scale messaging backbone that enables communication between data processing entities. The Apache Kafka streaming platform consists of the Kafka core, Kafka streams, and Connect, and it's the foundation of Confluent platform. Now, let's go with the Kafka core. At the core of the Confluent platform is Apache Kafka. It makes the configuring, deploying, and managing Kafka less complex. Basically, it is smoothing the task of configuring, deploying, and managing the Kafka. Kafka Streams is an open source solution that you can integrate into your application to build and execute powerful stream processing function. Kafka Connect ensure Confluent tested and secure connectors for numerous standard data systems. Then we have Elasticsearch. It's a distributed open source search and elastic engine designed for horizontal scalability, reliability, and stress-free management. R programming is a programming language and a software environment for statistical computations. R is a language that is widely used by data scientists, statisticians, data miners, and data engineers for developing statistical software and performing data analysis. Scala, it's a general purpose programming language. It supports functional programming and a strong static type system. Now, Python, we are all aware and we are also using. It has a design philosophy that emphasizes code readability. Python is a dynamic type system and automatic memory management, supports multiple programming paradigms, like it supports object-oriented, imperative, functional programming, and procedural programming. Then comes MQTT. It stands for telemetry transport. So the protocol uses publish and subscribe, extremely simple and lightweight messaging protocol. It is intended for constrained devices and low width, high latency, and unreliable network. So with this, we have come to the end of our presentation. Thanks for watching.